Hello class, this is Dr. Mike. And this week we're going to do a quick review of some statistical significance and correlation. It's very important we understand some of these basic concepts as we move forward and mature our skills with data analysis. So what does it mean by statistical significance? So really it means there's a high degree of certainty in the statistics behind the analysis. So we do have some sort of math. The data itself does support the significance of X causes Y, so a causation. But as we move forward, we're going to see you got to be very careful with this. A lot of times you got to know the data before you make a call that there is a cause in place. So we have different types of testing, and previously we talked about understanding our data. Is it continuous? Is it a Boolean, for example? This is going to help you when we do further types of testing. So for example, we actually can pull in a quick statistical measure between two variables within pandas. So we can import pandas and we can use, let's say, our data frame name .cov for covariance. And so give us an actual quick output between the two variables, showing us if there's a statistical measure associated between the two. So again, right away, very simple, one-liner. And of course, we can expand upon this, and using the help, you can find out there's several options here with our covariance analysis. Now, probably the biggest one too is correlation. This is really probably the heart of most analysis. Again, does A cause B? You understand the three types of tests, though. So again, let's go back. In our previous lecture, we talked about understanding our data. We also know that based on our data, which type of analysis we need to use. So the most common one is called Pearson's correlation. So it's a test for strength between the two continuous variables. For example, let's look at automobile data. So miles per gallon versus weight. So can I make the hypothesis that the more the vehicle weighs, the less miles per gallon it gets? And I can use pandas, the correlation test in pandas for this, which is the default correlation, the Pearson correlation. Again, because miles per gallon and weight are continuous variables. But let's say, again, we're looking at maybe data dealing with a grade or satisfaction scales. So we want to test the strength between two ordinal variables. So we need to actually call a Spearman correlation. So example, the student's grade versus a result of a survey where they 1 to 5, unhappy 1, and 5, very happy with the class. And so again, as the previous lecture we looked at, understanding our data is very important, and it's going to help us determine which test to pick. And there's the Kendall too, which also is based on variable ranks. However, it does not take into account the difference between the ranks. So it's good for discrete data. Probably the most common you'll see, again, is Pearson, again, which is the default used by pandas, and then the Spearman correlation. So again, let's talk about this means. Our data types. What does it mean? Is our data qualitative or quantitative? Again, if it's qualitative, it was fun. On a scale of 1 to 5, 5 being it was great fun, and 1 being I hated it, we have qualitative results. Is it quantitative? Again, miles per gallon or weight. But is it continuous? Is miles per gallon starting at, again, 0 miles per gallon, or getting 100 miles per gallon, or continuous? It can keep going. Weight, for example. Does the car weigh 1 pound, or does it weigh 1 ton? So we have continuous data. Discrete data is more, it's quantitative, but it's put into groups. So we have some grouping with continuous data. So understanding our data types is very important. So again, our pandas correlation. So we understand our data. We understand that the main correlations we can use, Pearson being probably the most common. I can actually plug in data frame name from pandas, .corr, and it'll give me a nice convenient correlation output. So example, let's say I have a data set called MPG data. From this, I want to pull out the miles per gallon column. I want to correlate that with MPG data weight column. So from this, I can actually get a nice output showing the correlation value. Now, of course, we look at miles per gallon versus weight. It's intuitive. I mean, we pretty much straightforward, right? We know what weight is. We know what miles per gallon are. We basically trust that. And if I tell you that the car weighs more, it usually gets there's a correlation. We usually see less miles per gallon for heavier vehicles. You could probably walk away from that going, yes. But let's say we're dealing with data that's a lot as clear as this. We can't just imply causation just because the correlation factor that was returned from our past result is almost a 1 or negative 1. Negative correlation, positive correlation, for example. I'll give you an example of that. This is actually a paper from Stanford posted here on stork data. And these researchers use full data analysis to show that more babies have been delivered since the stork population has increased. So based on this, can we safely assume that more storks are delivering more babies? So again, I think us as adults will go, well, no, of course not. We know that storks don't deliver babies, but one could walk away from this saying, well, yeah, it does. There's a correlation there. It's a positive correlation, and we see that the number of storks have gone up. So there's a birth rate. So again, this actually paper is posted here, and you see the link. It really is just as a humorous poke to really be sure you understand the data you're looking at. And this goes again deeper than just understanding if its normality, its having kurtosis, its averages. It's what is the data itself? What are we actually looking at? And you might get into some scientific realms where it cannot be, maybe it's not clear what that data means and what the correlation means. So it could actually pose more questions, but we gotta make sure we just don't come away with this. Another example would be, I can probably get data showing the rate of Diet Coke consumption and the rate of car accidents have both increased. So hence, can I assume that Diet Coke causes car accidents? Again, that's probably not a safe assumption. So again, understanding the data is very important. This helps infer that result from correlations and causations. So our pandas is just going to give us the mathematical output, but I think as data analysis, data scientists, we need to basically be able to infer that properly. Other things you could definitely infer, and these are a little more simpler. Let's go back to our previous example from our previous lecture about baseball stadium owner wants to know, do we sell more beers? What's the average sales of beers when our teams are winning versus the average sales when they're not winning at home games? So that's a valid business question. So what does average mean? Well, there are several averages out there. So most of the time you actually can get them all. It's probably good just to go and compute all averages. And one first one being the mean. This, of course, is what we typically know by the average, right? All the numbers together divided by the number of numbers itself. So again, we have these numbers here, 125, and there's 5 numbers total. Gives us an average of 25. It's important if you just say the average of 25, that can be not clear. You want to go ahead and say the mean average or the average mean is 25. Because we can also compute, take the same number set or take a number set and compute the median, which is really the middle value. Like in this case, we have these numbers here. We have the median of 6. An important place you might see this is with incomes and maybe with home values. Definitely with home values. I know it's look at the mean and median. An example is, let's say this is $300,000, $600,000, and $1 million. This block, this property, if I did a mean on this, this number would increase greatly because of the $1 million house on the block. So we want to definitely understand our data, understand what the average is. So again, I would post this as a median average of 6. And of course, the mode. The mode is really which appears the most often. So in this data set example, we have 3, 3, 6, 13, 100 again. There's 2 3s, so 3 is the mode. That's a big difference from the median. So again, as we look at our output, it's good to make sure we state with detail what we're using and what we see. Another one, of course, is the range. This is a nice one. This tells us how broad our data set is. The range being 97 here, the largest is 100 and the lowest is a 3. It gives us a range of 97. So with a really small range, that can sort of almost describe the data set to us. So mean, median, mode, and range are very handy. And again, as we go through this course, understanding your data and understanding correlations and how to interpret those properly is going to be very helpful in your skills as a data scientist. Thank you.